Okay, so pictures for energy 2, 1 through 4. The first one, number 1, a car is going to coast up a hill, and it's moving very fast, and there's this very tall hill, and of course, you got to draw a good car here. Here's the car, going 23 meters per second. And it turns out we know the mass of the car, right? And then the question is, how high is it going to go? What's its velocity at the highest point? 0. And why is it 0? Because if it's not 0, it's not at the top, right? It's not as high as it's going to go, right? So what is this probably? Is this probably kinetic turning into potential, I'm guessing, right? Okay, so this, I think this is not too hard. On number 2, though, it says, solve the problem, only what if it lost 150,000 joules of energy to friction on the way up? And kids solve this 2 different ways. One way is to figure out the kinetic 50,000 from that and then figure out how high it goes, right? The other way to do it is to say that 100,000 is one of those places where the energy goes. I'll let you wrestle with that one, right? And then this one, number 3, is it's going down the hill, I think, but it doesn't really matter. Okay, so it's going at this speed at the top of the hill, and that's a car. Kilograms, that says kilograms. It clearly says kg. It's very clear. There's no arguing with that, right? Okay, this one is moving at the top of the hill, and then you've seen these before, right? So this is not terribly difficult. The question is, we know the velocity at the top is 12 meters per second, right? Okay, we know the mass, etc. And on number 4, now it's getting interesting, and the rest of these will get somewhat interesting when we introduce force and distance, right? So it fires this space probe. Here's a space probe, okay? Is in space, and it's 516 newtons of thrust for 32 meters. That's a space probe. Here, I'm going to make it better here. Now it's better. Isn't that better?
Yeah.
There we go. Notice that this one, there's no MGH. This is in deep space. There's no MGH. I think this is one thing turning into one thing, right? 1 to 1, I think, is what it is. But here we have it. Don't laugh at the hiccuper. That's not very nice. I had a girl last year that was a chronic hiccuper.